class, and welcome to our week 3 lecture here for our CIS 2850 course. In this lecture, we're going to be covering topology, modifiers, and scene organization within Blender. So, as an introduction, in the previous lecture, we learned how to create and edit basic geometry. So you should now know how to move, scale, rotate, and extrude meshes, okay? And this lecture is going to build on those skills by focusing on how models are structured and managed, okay? So we're going from making shapes to modeling intentionally. So early modeling is often about making something look correct, but as models become more complex, structure matters just as much as the looks, right? So structure becomes just as important as appearance. Clean geometry behaves better, organized scenes are easier to work with, and good habits early prevent problems later. So this lecture is very much about developing those early good habits, okay? So why does this lecture matter? Modeling without structure can lead to shading issues, it can lead to difficult edits, and it can lead to problems when adding detail later. And these are just a couple of things that modeling without structure can lead to. But luckily, Blender provides tools to help manage complexity, okay? And learning these tools early will save us time throughout the semester and throughout our career in working with Blender. So this is a foundation lecture and it's not a finishing lecture, okay? So these are the big 3 ideas of this lecture. We'll talk about topology, which is how geometry is arranged and connected. We'll talk about modifiers, which is using non-destructive tools to work smarter. And then we will talk about scene organization, okay? Then that's keeping models and scenes manageable as they grow. And it's important to know that these ideas work together, not independently. So what is this lecture not about? This lecture is not about materials and textures. It's not about lighting or rendering. And it's not about sculpting fine details. We're going to get to those topics a little bit later in the course. And obviously, what we learn here is going to be a foundation for, these other topics that we learn later in the course. So think of this lecture as learning how to build a strong framework before adding polish, okay? And how does this fit into the course? So where we are headed. Clean topology supports sculpting and animation, which we will cover in later weeks in the course. Modifiers are used throughout modeling, not just once, so it's very important to have a good understanding of modifiers, especially the ones that are used frequently, and it is important to know how and when to use them. And scene organization becomes essential in projects and final work. It is very important to keep your scene organized. And so that is why we are also covering that in this lecture. So by the end of this lecture, you should start thinking less about tools and more about workflow. So let's start with understanding topology, okay? So in 3D modeling, how geometry is arranged matters just as much as the shape itself. And this underlying structure is called topology, okay? Good topology makes models easier to work with and more reliable. And it is important to know that topology is about structure, not style, okay? So what is topology? Topology describes how vertices, edges, and faces are connected. It's not about how detailed a model looks, it's about how clean and predictable the geometry is, okay? And 2 models can look identical but have very different topology. And that's because topology works with vertices, edges, and faces. Okay. So it's important to know that having good topology is incredibly important. And that just because 2 models look the same, it doesn't mean that they have the same topology. Okay. So appearance versus structure. Note that looks can be deceiving. Okay. A model can look correct at first glance, but poor topology will often reveal itself later on down the line when modeling, and it can be a real hassle to clean up, okay? Some common problem areas are strange shading, pinching or dents, difficulty adding detail, and unexpected behavior when editing. So, topology problems usually show up after the fact, and that's why it's important to consider it and learn about it early on in the modeling process. Okay. So, why does topology matter? Well, clean topology deforms better, it shades more smoothly, and it's easier to edit. Messy topology can cause visual artifacts, it can make making changes harder, and it can create frustration later. Okay. Good topology reduces technical debt in your models. And what this basically means is that technical debt usually is it's this idea that you'll have more work down the road if you do the simpler option right now that just gets results but isn't necessarily the best way of doing something, right? So just because you can get the looks part correct right away and it's much faster than taking the time to have clean topology, later on down the line, you'll have accumulated technical debt where it'll end up taking you way longer to fix the mistakes you made instead of just doing it right the first time, right? So that's why topology matters, and it matters early on because you want to avoid having to add a ton of work and time into your already busy work in creating different Blender models, right? So topology and shading. So how does topology affect shading? Well, lighting calculations rely on face normals. So irregular geometry can confuse shading, and uneven faces often lead to visible artifacts. And even without textures, topology affects how light behaves on a surface. Okay, that's important to know. There's also topology and deformation, or deformation, I should say. Why does structure matter for movement? Models that bend or animate rely on predictable edge flow. Okay. So poor topology causes collapsing geometry, sharp creases where they don't belong, and unnatural movement. Okay. So even simple animations benefit from clean topology. And then there's topology in game development. Okay. There's some real time considerations. So game engines draw every triangle every frame. Okay. So efficient topology helps maintain performance, it controls polygon counts, and it avoids unnecessary geometry. So good topology supports both visuals and performance when it comes to game development. So, what are some common topology problems? Issues that you should learn to avoid are randomly placed edges, long stretched faces, dense geometry in some areas and sparse geometry in others, and geometry added without planning. And a lot of these issues actually come from modeling without intent, which we've talked about quite a few times already. Uh, and this just kind of reinforces it. When you begin modeling, you should model with intent. Um, and topology is about planning. Okay. So good topology comes from intentional edits, predictable edge placement, and understanding how a model is going to be used. And this is an important one. You don't need perfection. Okay. It's not about having perfection, but you do need awareness. Okay. Topology is a skill that improves with practice, not memorization. So you can read the book chapter and watch the lecture as many times as you want, but until you actually get into Blender and practice, you're not going to improve your skill set. So let's move on to talking about controlling shape with edge flow. Okay. So topology becomes useful when it is applied intentionally. And edge flow describes how edges follow the form of a model. Good edge flow helps control shape with minimal geometry. So, what is edge flow? Well, edge flow refers to the direction and continuity of edges. Edges should follow the natural shape of an object, and consistent flow produces predictable results. Okay. Why does edge flow matter? Well, it controls how a surface bends and deforms, right? We talked about that in regards to animation. It affects shading and smoothing, and it makes later edits easier and cleaner. Okay. Now we can talk about edge loops. An edge loop is a continuous path of connected edges, okay? Edge loops often wrap around a model, and loops define form and structure. So, some common uses of edge loops are controlling thickness, supporting sharp edges, and guiding deformation. Okay. So, for selecting edge loops, very simple. Edge loops can be selected very quickly. What you do is loop selection makes large edits efficient. So, the typical workflow is you will switch into edge select mode, right? So if you're in Blender, you're going to, if you're in object mode, you'll tab into edit mode, and then you can press 2 on your keyboard, and that will put you into edge select mode. Then you just alt click on an edge to select the loop, and we'll look at that a little bit later here. We also have this neat thing called loop cuts. So loop cuts add new edge loops to a mesh. They increase control without reshaping the entire model, and they are commonly used to refine form. So the key idea of loop cuts is to add geometry only where it is needed, okay? And remember, use loop cuts intentionally. So loop cuts should always support the shape that you want. Placing a loop close to an edge increases sharpness, and spacing loops evenly produces smoother transitions. So loop placement affects both form and shading. Okay. So why don't we take a look at loop cutting in action? And I have Blender open here. So I'll go ahead and split my windows and make sure we can see these slides. So these are the steps in Blender 5.0 plus. Okay. So we'll start with the default cube, which I already have here is the default scene. Make sure the cube is selected if it is not already. We can go ahead and tab into edit mode. If you'd prefer, you can use the drop down here to go into edit mode. And then if we press 2, we will be in edge select. Again, you can click edge select right up here at the top. And then now we're going to press Control R, okay? And what this does is this puts us into our loop cut, okay? And you can see, if you see that yellow square that appears, that's the horizontal loop cut that we can make. And then we can also make a vertical loop cut, okay? So that is the yellow preview loop. While we're sitting here, if we scroll the mouse wheel, you can see that we can add loop cuts, right? And if I scroll it a lot, you can see we're adding a ton of loop cuts here, okay? For our purposes, I just want to add 3 loop cuts here. So what you do is you left click to confirm the cut. And then what you can actually do is you can move the mouse and you can decide where your loop cut is going to go. Okay. I'm just going to place my loop cut where it is. So we left click to confirm, and that places the loop cut. We have made our loop cut now in our cube. Okay. Do note that you can then manipulate faces, edges, vertices independently from one another. Okay. So in the example in the slides here, I move a face. What we can do is we can hit 3 to go into face select. We'll grab this face right here. And then if we press G and then X, we can drag the face along the X axis. And we can actually drag that face itself as its own face, and it doesn't manipulate the other faces around it, right? So that is a really cool way to use loop cutting and be able to edit our models. Okay. There's also edge rings. So an edge ring runs perpendicular to edge loops. Rings are useful for certain selection and editing tasks. Note that not all geometry supports clean edge rings, so understanding both helps with advanced selection. And edge rings run perpendicular to edge loops, okay? Moving on, we can look at edge flow and subdivision. So subdivision smooths geometry by averaging surfaces, okay? And good edge flow will produce clean, predictable smoothing, and poor edge flow creates pinching and artifacts. So subdivision reveals topology problems quickly, okay? And you can see here, we can use edge flow as a design tool. So edge flow helps define form without excess geometry. Fewer well-placed edges are better than many random ones, okay? So intentional flow leads to cleaner models. So let's take a look at sharp versus smooth edges, okay? So we still have our cube here selected, and we're in edit mode. So I'm going to make sure the cube's selected. We're going to go in edit mode. What we can do is we can select the newly added edge loop. Okay. So the way we do that is we alt click, right? We need to be in edge select. So we'll hit 2 and we'll alt click on our loop here. And you can see that the loop is selected from the yellow lines and the white line here on this edge. And then what we're going to do is we're going to press G, and then we will press X to go ahead and slide it along the X axis. So I'm going to go ahead and slide this over here. And why don't we slide it, our object, and make it look like this. And I'll left click to position that where we want it. So we've created a nice little funky shape here. And then now what we can do is we can add a subdivision surface modifier. So let's switch into object mode by pressing tab. We'll go to the modifiers tab, which is this wrench icon right here with our cube selected. And then we can click on add modifier. And in our search, we can actually search for subdivision surface modifier. Mine is right here. So I'm going to go ahead and click it. And you'll notice immediately that our model got a little bit smoother, right? And this is a sneak peek at modifiers. So we can actually toggle the visibility on and off. So you can toggle the visibility of the modifier on and off there. And then you can also go into wireframe to see what it looks like and how it changes the model with wireframe on, okay? So I'm going to go back into our solid viewport shading, and we'll scroll down here. So make sure we have this on. So the levels viewport is the number of subdivisions that it makes in the viewport in Blender, right? This is the levels viewport right here in our modifier. And then the render is the number of subdivisions for when we're ready to render. So if they're the same, it'll look the exact same way when it renders. And do note that many modelers, when working, will keep the levels viewport at a lower number like 0 or 1 when they're working to make sure Blender doesn't slow down at all. And then, you know, if you wanted to see what it would look like in the finished render, you might pop it up to 3 real quick and be like, okay, that's what the model's going to look like in the finished render, but to not slow things down, we'll keep it at 1 or at 0, okay? So that is a very common modeling technique to help not slow down the 3D viewport. Here are some common edge flow mistakes. I'm going to maximize this again and zoom in. Some of the major mistakes, right? Adding edges without purpose, breaking loops unnecessarily, creating uneven or zigzag patterns, and overcomplicating simple shapes. Most edge flow issues come from rushing. So again, when you're modeling and working in Blender, it's okay to take your time. It's a time-consuming task, but taking your time helps prevent mistakes and helps prevent early errors and makes you a better modeler. So thinking in terms of flow. Look at models as connected paths, not isolated faces. Consider how geometry will be edited later and make changes that support the overall form. And remember that edge flow improves with observation and practice. So again, the way you get better at modeling and edge flow and topology and everything in regards to Blender is by actually doing in Blender and actually modeling yourself in Blender. Okay, you got to get hands-on with Blender. So now we'll talk about modeling smarter with modifiers. Okay, so as models become more complex, manual editing becomes inefficient. And what Blender does is it provides tools to automate repetitive modeling tasks, and these tools are called modifiers. Obviously, in the slides here and in the lecture, I'm not going to go into all the modifiers. There will be quite a few modifiers that I'm not even going to touch on. As long as you read the chapter in the book, the author does touch on all of the modifiers that exist, but doesn't go in depth on all of them, just some of the more commonly used ones. But you can feel free to actually look up those modifiers and look into them a bit more if any of them sound interesting to you. And obviously, feel free to play around with whatever modifiers you want. That's the best way to sort of understand these modifiers is using them within Blender and getting familiar with them. So, what is a modifier? A modifier is an operation applied to a mesh. It changes how the mesh behaves or appears. And do note that the original geometry remains unchanged, and modifiers affect the mesh without permanently altering it. So the cool thing about a modifier, if we open this really quick, is that if I get rid of the modifier on my uh, 3D model here, you can see that the original geometry has not been affected. Okay, so that is a really handy thing about modifiers. So modifiers are non-destructive by default, right? You can add a modifier, adjust its settings like we did before, and then you can disable or remove it, and the base mesh will always be preserved. So that is incredibly handy, especially if you just want to see how a modifier is going to affect the mesh that you're currently working on. You don't have to worry about it kind of ruining your model um, if it didn't do what you wanted it to do, right? You can always just remove the modifier. So why are modifiers useful? Well, they reduce repetitive manual work, they make complex changes easier to manage, and they also allow you to adjust models late in the workflow, okay? And we should also discuss the modifier stack. So modifiers are applied in a top to bottom order. So what that means here in Blender is that if you have multiple modifiers, I'm just going to add 2 as an example. If we have here at the bottom, we have our mirror modifier, and at the top, we have our smoothing. This means that the smoothing modifier is going to happen first, and then the mirror is going to happen. Okay, if we switch these around, then the mirror happens first and the smoothing happens second. Okay. So for some modifiers that won't affect each other, but for other interactions, it will, they will affect each other. The order will affect each other, I should say. So changing the order can change the outcome, right? And there is a difference between viewing and applying modifiers. So modifiers can be visible in the viewport and used during rendering. But when you apply a modifier, it makes its effect permanent and it converts generated geometry into real geometry. So be very careful when you're applying modifiers. And as a note, there's times when you should not apply a modifier. So during early modeling, you shouldn't. While experimenting with shape, you shouldn't. And when flexibility is still needed, because applying a modifier really limits what you're able to do with a mesh. Okay. And a note on modifiers and performance. So modifiers can increase the amount of geometry Blender has to process. And because of that, some modifiers generate large amounts of temporary geometry. So performance impact depends on modifier type, modifier settings, and order in the modifier stack. So some practical considerations: keep the viewport levels low while modeling, increase render quality only when needed, and disable modifiers temporarily if the viewport slows down, which we kind of touched on before when we talked about our smoothing modifier. And modifiers as workflow tools. So modifiers aren't just effects, they are part of a modeling strategy, and many professional workflows rely on them heavily. So tons of professionals use modifiers all the time. It's not like a cheap way, like you're not as good of a modeler if you don't do it by hand, right? There's some stuff that just doesn't make sense to be done by hand. So it's okay to use modifiers, and I'd recommend using modifiers if the task is appropriate for a modifier to do for you. Um, and again, back to topology, modifiers work best with clean topology. So modifiers rely on predictable geometry, so clean topology will produce better results, and poor topology is going to be amplified by modifiers. And that's kind of where the technical debt comes back to bite you, is if you have poor topology and then you apply some modifiers, you're going to be in a real bad state with your model. So again, just make sure you have clean topology, especially before you start applying modifiers. Um, and thinking procedurally, right? So procedural modeling means defining rules instead of manually repeating actions. Modifiers allow Blender to handle repetition and symmetry. So you focus on the structure while Blender handles the details. So, for example, here's some examples of procedural thinking. You have using a mirror modifier instead of modeling both sides, right? This is especially handy if you're doing any face modeling, right? It's way easier to do one side of the face and then have it mirrored instead of trying to do the entire face and one eye's bigger than the other or one ear is higher than the other. The mirror modifier really simplifies that. Using subdivision to smooth geometry instead of adding faces manually, and using an array modifier instead of duplicating objects by hand. So we can model procedurally with a mirror modifier. I'm going to put this to the side here and open Blender. And we can go ahead and delete our smoothing here. And I've actually already applied the mirror modifier, but if you haven't done it for yours, you can select the object and enter edit mode, press tab, right? Oops, didn't want to tab in there. I was going to tab in here. So we are in our edit mode in here. Delete half the mesh or a portion of the mesh. So you can select some faces and press X to delete them and choose faces. Return to object mode, and then in object mode, you can add the mirror modifier like I have here. And then I would recommend keeping clipping enabled. Okay. This just prevents gaps along the mirror axis. I think that it's very handy and you'll usually want that one enabled. And then you can continually modeling one side. You can continue modeling one side only. And the mirrored side will update automatically, right? So if I disable this real quick, you can see which side is the non-mirrored side. So if we were to tab into edit mode here, and if I was to just select this edge and press G and then X, you can see that as I move this edge forward here, it actually affects the mirrored side as well, right? So that is a super handy tool that you'll be able to use. And it helps because you only have to make an edit on one side for it to affect both sides, right? So that is incredibly handy. And then just a summary really quick of modeling smarter. So modifiers automate common modeling tasks, so make sure to utilize them whenever you're able to. They preserve the original mesh and they support flexible, iterative workflows. So they're incredibly handy. Now we'll take a look at modifiers that you'll be using all the time when modeling. Some modifiers appear in almost every Blender project, and these modifiers solve common modeling problems. And learning a few well is better than memorizing many, right? So being able to use the few that are incredibly handy is much better than knowing how to use many, many modifiers, but not really fully understanding them, right? So first is the mirror modifier. It creates symmetrical geometry across an axis, and it eliminates the need to model both sides manually, right? We kind of talked about that already. It keeps geometry connected and consistent, and some common uses of the mirror modifier are for characters and creatures, vehicles and props, and architectural elements. And why is mirror so important? Well, it reduces modeling time significantly. It prevents asymmetry in your models, and it makes later changes easier. And these are some of the key options with the mirror modifier. So you have axis selection on X, Y, or Z. Clipping, you check that, and it prevents vertices from crossing the mirror plane. And then merge, which joins geometry along the mirror seam. These are all really key and handy options that the mirror modifier provides. We also have the subdivision surface modifier. This smooths geometry by subdividing faces, and it generates additional geometry mathematically. So it does not permanently change the mesh is the other thing to consider. So when should you use the subdivision surface? Well, when a model should appear smooth, you should probably use the subdivision surface. When edge flow is clean and intentional, it's a good time to use subdivision surface, and when sharp edges are supported by nearby loops. Um, and a note on subdivision versus manual geometry. Manual geometry requires many faces and it's much harder to edit later, but subdivision actually uses fewer base faces. It produces smoother results and it preserves flexibility, right? So subdivision is a super handy modifier. And then we have the array modifier. So the array modifier creates repeated copies of geometry automatically, right? And copies are generated procedurally, not duplicated manually. So the original mesh remains the source for all instances, okay? So some of the key controls of the array modifier are count, which is the number of repetitions, offset, which is the distance and direction between copies, and relative versus constant spacing. And this is percentage based or fixed units. And remember, arrays are ideal when repetition needs to stay consistent. Maybe you have a row of chairs or a set of chairs that you need. And instead of actually duplicating each one individually, you can use the array modifier. So common uses for a array modifier is fences, railings, and stairs, windows and columns, and mechanical parts with repetition. So why do these modifiers matter? Well, these modifiers solve common modeling problems, right? Symmetry, smoothness, and repetition. They also help reduce manual work and repeated edits, which is a huge time saver when you are modeling. And they keep models flexible as designs change. So, using these modifiers early saves time later, prevents inconsistent geometry, and encourages cleaner topology. And also note that modifiers work together, right? So, multiple modifiers can be combined in a single workflow, and each modifier builds on the result of the previous one, right? We were talking about the top to bottom structure of modifiers. And changing modifier order can change the final shape. So, for example, mirror before subdivision for clean symmetry, array before subdivision for smooth repetition, and subdivision last to smooth the final form, right? So, those are some examples of how modifiers can work together. And also, understanding how modifiers interact is more important than memorizing settings, okay? Again, you can memorize the settings all you want, or you can memorize, the buttons or the hotkeys. But if you don't understand how everything interacts, then you're not going to get as far as you'd like to, right? So that's why practice becomes perfect, because the best way to understand is to actually do. Here are some commonly used modifiers as a quick reference. We talked about the first three, but there's also bevel, which rounds or softens sharp edges. You can use it when edges look too sharp or unrealistic. There's the solidify modifier. This adds thickness to surfaces. Use it when modeling walls, panels, or shells. The Boolean modifier, it combines or subtracts shapes. So when you're cutting holes or merging forms, you can use that modifier. So, a summary of core modifiers. Mirror, subdivision, and array are used constantly. They automate some really common modeling tasks and they encourage clean, efficient workflows. So, be sure if there is a time where those are appropriate to be used that you are using them. So, now choosing the right modeling approach. So, Blender offers multiple ways to achieve the same result. The goal is not to use every tool. The goal is to choose the approach that makes sense for the task. Okay. So good modeling decisions save time and prevent rework. So, manual geometry versus modifiers, right? Some changes are best made directly to the mesh, and others are better handled by modifiers. So, knowing the difference helps improve your workflow. And again, to emphasize, this choice depends on intent, not preference. So, when should you edit geometry directly? You should do it when making one off changes. You should do it when shaping unique details. And you should do it when precise control is required. So, some examples of this: moving individual vertices, adjusting edge flow, and refining silhouette. Now, on the flip side, when should we use modifiers? So, when symmetry is involved, when repetition is required, or when smoothness is needed, these are all great times to be using modifiers. And again, modifiers excel at automating structure, maintaining consistency, and preserving flexibility. Um, Avoid over modeling, right? Adding geometry too early can cause problems, and dense meshes are much harder to edit. So, more faces does not automatically mean better results. Okay. And I think this one's really important. Plan before you model, right? Consider how the model is going to be used. Think about future steps, right? Subdivision, animation, exporting. Think about just everything in regards to the model, because early decisions support your later work, right? So you should consider how the model is being used. You should consider what it's for. You should consider some of the different steps you're going to need to take and some of the different modifiers and things you're going to need to do to the model. This is all important to consider before you begin modeling something. And here's a practical rule of thumb. If you're repeating the same action, consider a modifier, but if you're shaping a unique form, edit the geometry directly. Okay. And remember that order matters. So the order of operations affects results. Adding modifiers early enables procedural workflows, and applying modifiers too soon will limit your flexibility. Okay. And then learning through iteration, right? Modeling is rarely linear. You should expect to adjust topology and modifiers as you go, and expect to revisit earlier decisions as models evolve. That's just natural as you're modeling, so don't really expect that you're just going to perfectly model stuff on the first go. There may be outliers where you do model something and you're happy with it the whole way through and you don't need to go back. But most of the time, you are going to need to go back and edit things that you've done in your model. And developing good habits, right? Choose the tools that you use intentionally, favor flexible workflows, let Blender do the repetitive work for you, and remember that good habits scale as projects become more complex. So developing these good habits early is better than saving them for later. Okay. Now we can move on to keeping your scene organized. Okay. So as scenes grow, organization becomes essential. Disorganized scenes slow down modeling, and good organization supports clarity and efficiency. So, why does scene organization matter? It makes complex scenes easier to understand, it reduces accidental edits, and it saves time when returning to a project later. So, as a quick reminder, a difference between objects and meshes, each object has a name, a transform, and a mesh, okay? And scene organization works at the object level, not the mesh level, okay? So, we need to be good at using the outliner effectively, okay? The outliner shows all the objects in the scene, and objects can be selected, renamed, and hidden. And the outliner is a management tool. It's not just a list of everything in the scene, it is a management tool. Um, we should, with our objects, we should name our objects clearly, right? So default names can become confusing quickly, especially if you start adding just like a ton of different default objects. So meaningful names improve readability. So for example, instead of cube 001 and cube 002, you could have tabletop, table leg left, and table leg right, right? Meaningful names are incredibly important, and you should expect to have meaningful names for all of your assignments in this course, as it makes the scene much more readable to me because I don't know what you were modeling when I go into your actual like blend files, right? I have no idea what you were working on. I have to open the files and look around and see, and it's much easier if you have meaningful names like this so I can see what each object is supposed to be. Um, then we also have collections, right? Collections group related objects together, and objects can belong to one or more collections. So collections can be very helpful in managing complex scenes. And we can organize with collections, right? So we can group objects by function, by location, by asset type, and we can also hide or isolate collections as needed. So for example, we may have some collections named furniture, environment, and reference objects. Um, do note that objects and collections can be hidden and disabled for selection, and this can be really helpful for preventing accidental edits and improving focus while working because things will seem just a little bit less cluttered. I'd recommend keeping the scene clean, right? Remove any unused objects, delete test geometry when you're done with it, and avoid leaving unnecessary duplicates in your scene. And of course, we keep throwing around this workflow, so we should define what workflow is. A workflow is how you move from an idea to a finished model. It includes the order you work in, the tools that you choose, and the habits that you develop. Okay. And a good workflow reduces rework, keeps models flexible, and makes changes easier later. Okay. And I would make organization a workflow habit. Okay. So organize as you go. Don't wait until the very end. It can just become annoying at the end. If you just stay organized as you go, then you really don't have to worry about organization that much because you'll just always be organized. And small habits prevent big problems later. So just remember that as you're beginning to form these good habits. There is a guided demo clean modeling workflow document that I've provided on D2L that I would recommend looking at and going through. It is a Word document that you can go through, very handy. The demo shows how several of the concepts work together, and it looks at edge flow, modifiers, and scene organization. And the goal of it is to demonstrate workflow, not produce a finished model. So I would recommend going through that. What should you pay attention to in it? You should pay attention to when geometry is edited manually, when modifiers are used instead of repeated edits, and how changes remain flexible throughout the process. So to summarize really quick, modeling is not just about appearance, right? Structure, planning, and organization matter early, and good habits reduce problems later in the workflow. Um, and again, how do these concepts fit together? Topology, edge flow, modifiers, and scene organization. Topology determines how geometry behaves. Edge flow controls shape and deformation. Modifiers allow flexible, non-destructive modeling, and scene organization keeps your projects manageable. Okay. So looking ahead, clean topology supports smoother shading, easier editing, and better results with modifiers. Organized scenes scale into larger projects, and as we begin to work with Blender more, obviously our projects will get much bigger. So it is important to get organized early, and workflow decisions become more important as complexity increases. So that is all for this lecture. I'd recommend taking a look at the Word document, the little mini demo document that I've provided on D2L. It'll be very handy for you. And I will see you guys in the next video.